Hi, my name is Miguel, and I'll be explaining how the HIPS works and how it is simulated through these two PLCs, High Matrix F35s, and this human machine interface screen. Hypothetically, we'll be placing this safety PLC to a subsea oil rig application that will be offshore, and this one will be hypothetically placing in onshore where it is connected to a computer where we can monitor the HIPS system. The HIPS system has three, the third one is right here. We have three analog inputs which work as a pressure transmitter, and this is where we control the pressures. Also, we have the digital input, which is a switch where the operator can flip the switch to trip the system in case of an emergency. Here we have the HMI screen. As you can see, all three valves are closed, so we'll open them. We'll energize the valves. As you can see here, also we have the three pressure transmitters that are about 3,000 psi. To make sure that the pressure transmitters are working fine, we set a deviation of 200 psi. If any of the pressure transmitters are over that threshold of 200 psi, it will show a deviation alarm indication on the screen. So I will set, right now it's at 3,000, so I will set the first pressure transmitter a little higher, and as you can see, we have a deviation alarm. This will give the operator or whoever is monitoring the HIP system to either fix or replace the transmitter that is not working. So now we set it back to regular, to its normal state. The the deviation alarm goes away. We also have a safety function where we do a logic of 2 out of 3. Whenever two out of the 3 pressure transmitters are over the threshold that we placed of 4,000 psi, meaning if 2 of the pressure transmitters are over 4,000 psi, these 2 valves will close. These 2 valves right here. So right now I will raise the 2 over 4,000, and after 10 seconds, as you can see here, after 10 seconds, the system will trip. We pick 10 seconds because pressure fluctuates, so we don't want the system to keep tripping if we leave it at 1 second. So that wouldn't be a practical way of using this system. Okay, so as you can see, also we can't open the valves because this is a safety protocol of the HIP system. I can't open these valves unless I get out of the trip condition. So I'm gonna set these 2 back to normal, and this will remove the trip condition. So we'll put it back to about 3,000. The deviation alarm will go off as well, and now we can see that they're about 3,000. We can open the 2 valves, and we're back to our normal condition. Another safety function is that we can trip the system in case of, let's say, two of these transmitters are not working and there is a leak of some sort. The operator can, that's offshore in the local location, can switch this and trip the system. As you can see here, the two valves are closed and it's at fault condition. Again, I cannot open these two valves, so I'll have to set this back to normal by flipping the switch again. And now I can go back to my normal condition. Another way is to, let's say the switch does not work, and two of the transmitters, pressure transmitters, does not work either. We can send a command from this PLC to send to this one through the HMI screen. These are usually communication through RTUs, so we click the emergency stop and the valves close. Now we're back to fault condition. Again, can't open the valves because they are in they're in a trip condition. So we make sure that the switch is off, and well, now that I come back and re-energize the the valves, now I would like to show you the alarms. This will show where the events happen of the alarm events, or well, red means alarm was activated. This will give the operator the time of the event. Blue means that the event is dealt with, as in it's in normal state. And if I press acknowledge all, it will turn to green, meaning that it has been acknowledged. For trends, we can show the fluctuation of the pressures. Right now, well, we have it already set to a certain pressure. Let's say I raise a little bit of the first one and the second pressure transmitter. I'm not going to mess with the third one because the third one is pretty sensitive. As you can see, since the signals are moving really slowly, you can see that it was raised at a certain time. This is where the operator can kind of see when the pressure has fluctuated. And that is the HIP system.